this is Mercury. Mercury is an interesting planet. It's tiny, tiny, tiny. It is, technically, it's the smallest planet in the solar system right now, depending on whether you like Pluto or not. And I will argue about the definition of planet later, again, if you want me to. It's an interesting planet because it orbits the sun so closely, about 36 million miles, something like that, 50 million kilometers, something like that. Because it orbits the sun closely, it never gets far from the sun in the sky. If it orbited the sun really far out, then if the sun were here, we'd see it over here. But it only does this, so whenever the sun's up, Mercury's very close to it. The only time you can see Mercury clearly is right after sunset or right before sunrise. And it never gets far above the horizon. I should say, when it's easy to see. When the sun's up during the day, Mercury is there too, but it's tough to spot. With a telescope, you can see it. I've seen Mercury during the day. It's kind of neat. But it's tough to study. It never gets far from the sun, which means there's glare from the sun. When the sun sets and you can see it well with the telescope, it's so low to the horizon, there's a lot of air in between you and it, and rising pollution and just crap in the air makes it tough to get really decent pictures of it. And so we sent space probes to it starting decades ago, but then we launched the Messenger probe, which has got it's Mercury Exploration Spaceship. I don't even know what it stands for. It's this long, ridiculously long acronym. But Messenger is really cool. It took a long time to get there. It's actually tough to get to Mercury, but it's been orbiting there for a while now and taking just spectacular pictures like this of this planet. To me, Mercury, there you go, just to confirm that you guys are right. There's a lot of interesting stuff about Mercury. It's littered with craters. It doesn't have an atmosphere. And so there's nothing to stop rocks from hitting it. Not only that, it occurred to me a couple of years ago, I was thinking about Mercury and its craters. And it occurred to me that it's because it orbits the sun so closely, things that get closer to the sun move more quickly, right? If you drop a rock and from some height up, it hits the ground. If you drop a rock from much higher, it's moving faster when it hits the ground because of gravity. Well, the sun has a lot of gravity. If I drop a rock and let it hit the Earth, it's going to be moving at some speed on average. But if I drop a rock from that same place and let it hit Mercury, it's falling towards the sun for a lot longer, so it's moving faster. So pound per pound, a rock that hits Mercury is going to be hitting it faster, which means it's going to make bigger craters. And I thought, it's like, that's really actually pretty interesting to me. And so Mercury has a lot of craters, and on average, they're bigger than they would be if they had hit the Earth, even though the Earth is much bigger than Mercury. So it's loaded with craters. It's got them all over the place, including its north and south poles. This is a picture, I believe, of the south pole of Mercury. And as Mercury orbits the sun, I'll just do it like this. It's sort of, here's the north and south pole. As it's orbiting the sun, if you're standing on say, the south pole of Mercury, as it's going around the sun just seems to circle around the horizon. It doesn't really rise and set. It's just like on Earth, where in Antarctica, on the first day of winter, for example, the sun will make a circle around the horizon, and then as winter goes on, it gets lower and lower and then never rises. Or in the summer, it makes a big circle in the sky and never sets. It's similar to that. On Mercury, you can be on the South Pole, and the sun will just really be right on the horizon all day long. So if you have a crater on the South Pole of Mercury, and that is a depression in the surface, if you stand on the rim, you see the sun go around in a circle. But if you're at the bottom of that crater, right, the rim is above you. That sunlight never gets to you because you're down in this pit. And so forever, for all year long, that bottom of that crater never sees sunlight. And it turns out rock is a really good insulator. So interestingly, amazingly even, you might say, even though the surface temperature of Mercury is 800 degrees Fahrenheit, the surface of Mercury is 800 degrees because it's so close to the sun. But in these eternally shadowed craters, that temperature can be incredibly cold, minus 300 degrees, even though the sun is shining just a couple of miles away, and it's hot enough out there to melt, zinc. You can have pools of zinc on the surface of Mercury. Just a few miles away, it can be so cold, it never gets warm enough to even melt water. And it turns out we have discovered ice in the bottom of these craters. And I assume a lot of you have heard about this. But I couldn't believe it when I heard it, because I thought, how could it possibly stay cold there? And I talked to one of the scientists, and he said, rock is a really good insulator. When it's a few miles thick, yeah, that heat cannot bubble through. It just is prevented from getting to that place. Well, where would Mercury get ice? And it turns out probably comets. There are comets whizzing around the solar system. They're filled with water ice. They're frozen. As they get near the sun, that ice turns into a gas, and it's moving around in the inner solar system, and Mercury plows through it as it orbits the sun. Sometimes these comets hit Mercury, and you get this big eruption, and then it settles down, and some of that stuff falls into craters. And over billions of years, it's accumulated. And it's probably just under the surface. There's probably quite a bit of water ice, and probably fairly pure water ice. And it's just covered with a little layer of rock from other asteroid impacts and everything, sort of raining down dust over them over billions of years. That is one of the most bizarre paradoxes I can think of. And it's similar to what's going on our own moon. Because when the sun is shining on the moon, it's very hot. But at the moon's poles, there are also craters that are so deep they never see sunlight at the floor. And so they have ice as well. And we've detected ice under the surface of the moon, again protected by a layer of dust and rock, so that it never goes away. And that's pretty cool. That means that ice can exist everywhere as long as it's protected. And we can use that. Water tends to be useful for human beings. We drink it. We can break it apart into oxygen and hydrogen, which we can then breathe and turn into fuel. So I'm thinking, breathing, drinking, showering, which is nice when you're out in space, and fuel so you can get around. That's pretty interesting. And that means there are probably asteroids loaded with ice as well. So it could be that the solar system is like a giant quickie mart. Anywhere you need is a convenient place to get what you need to live.